All right, today we're diving into a pretty wild idea in AI. It's a breakthrough that pulls from biology, from logic, and, believe it or not, from Pokémon. This is the story of the Ditto algorithm. And that brings us to the big question, which I know sounds a little strange. What can a Pokémon possibly teach us about the future of AI? Well, it turns out a whole lot. The key is in the Pokémon Ditto, which, as you might know, is famous for one thing, its ability to transform and mimic others. And that simple, powerful idea is at the heart of solving one of AI's biggest headaches. And here's why this matters. Just look at these numbers. A massive, powerful Llama 70V clocks in at a whopping 80 gigabytes. Now, look at the Ditto layer. It's less than 1 gigabyte. That's a reduction of over 99%. This isn't just a small improvement, you guys. This is a total game changer for how we can build and use AI. So the question is, how on earth is this even possible? To really get why Ditto is such a big deal, we have to talk about the problem it's solving. For the past few years in AI, the motto has pretty much been, bigger is better. But we're starting to hit a major wall with that approach. I mean, these models are absolutely massive, some with over 100 billion parameters. And sure, they're incredibly powerful. But that power comes at a staggering cost. They're computationally expensive, they suck up insane amounts of energy, and all of this creates a huge barrier. It makes it pretty much impossible to run these giants on our phones, our laptops, or even in our cars. They're just way too big. And this is where things get really cool. With this giant problem looming over the industry, a new hero has kind of emerged from the world of AI research. So let's meet the Ditto algorithm. Here's the secret sauce. Inspired by its Pokémon namesake, the Ditto algorithm doesn't start with any knowledge. It's a blank slate, just a generic neural layer. But then, it does something brilliant. It intelligently scans multiple, huge teacher models, finds their most important, most efficient parts, and then transforms itself to mimic just those best bits. The end result? A tiny, super efficient model that has the wisdom of giants. And hey, this isn't just a fun analogy. It's the actual scientific principle behind it. The algorithm's own creator, Anthony Pyper, calls it a framework inspired by biological mimicry. It's all about distilling, or boiling down, the essence of these giant models into something small, but just as potent. So, how does our little hero get all these powers? Well, this is the training montage. Let's break down how Ditto actually learns and evolves, because it's a fascinating process that pulls from 3 completely different fields. You see, the real genius of this algorithm is how it mashes up these ideas. It borrows the whole concept of evolution from biology, it uses a technique for knowledge transfer from AI, and it pulls a fundamental rule from mathematical logic just to keep everything on the right track. Okay, first up is its mimic power. This comes from something called knowledge distillation. That's just the fancy term for a small student AI learning from a big teacher AI. But Ditto totally supercharges this idea. It doesn't just learn from one teacher. Nope. It scans multiple teachers and copies only their absolute best, most effective layers. It's like creating a greatest hits album of the best pieces from all the other top AIs. Next is its secret weapon, a predictive power that comes from a technique called JIPA. Think of JIPA as a fortune teller. As Ditto is evolving, JIPA looks into the future and predicts where the next version is most likely to mess up. By knowing what's going to go wrong before it happens, it can steer the evolution in a much smarter direction, so it doesn't waste time on bad mutations. And finally, we have this safety switch. This is maybe the most brilliant part. It's inspired by one of the deepest ideas in all of mathematics, Gödel's incompleteness theorems. Now, to put it simply, this part recognizes that some problems just might not have a perfect solution. So if the algorithm gets stuck in a loop, making tiny changes that aren't actually improving anything, the Gödel bounds just kick in and say, all right, stop. It's like a dose of logical wisdom that prevents it from spinning its wheels forever. So you put it all together and you get this incredible 4-step loop. 1, scan the teachers. 2, morph and imitate their best parts. 3, use JEPA to predict the future and guide the next change. And 4, either evolve to get better, or, if it hits a dead end, the Gödel bounds halt the process. It's Darwinian evolution guided by a fortune teller with a logical safety switch. Pretty cool, right? So after all that training, after that whole montage, what can our hero actually do? Well, the results are, to put it lightly, absolutely astonishing.
Just let this number sink in for a second. 100 times.
That's what we're talking about here. A 100-fold compression in size. Taking that huge 80-gigabyte model and shrinking it down to a super lean 0.8 gigabytes. And here's the most mind-blowing part. It does all of that with less than 0.1% drop in performance. It keeps basically all of the power while shedding 99% of the weight. And the hard data proves it. I mean, compared to other compression methods, Ditto is just in a completely different league. Take MSE match. Lower is better, it means a more accurate copy, and Ditto's number is tiny. Then there's perplexity, which is a measure of how well the AI understands language. Again, lower is better, and Ditto wins. And when you get to the final size and the response time or latency, it's not even a competition.
And this chart just hammers home the real-world difference. Look at that response time. While other methods are taking about a second to give you an answer, Ditto does it in 1/100th of a second. That's the difference between a frustrating lag and a totally seamless instant conversation. It's just unbelievably fast.
Okay, so a tiny, ultra-fast, and still really powerful AI, what does that actually mean for us? This isn't just some cool academic paper. This breakthrough is genuinely opening the door to a whole new world of what's possible. So, what does this unlock? Well, first, sustainable AI. We can get all this amazing power while slashing the huge energy bills and carbon footprint. Second, it brings AI to the edge, and that's a huge deal. It means powerful AI running locally, right on your phone or in your car, without needing to connect to the cloud. And finally, and maybe this is the biggest one, this opens the door to truly agentic systems, AI that can actually evolve and improve itself over time. Which brings us to the final thought, really. The Ditto algorithm shows us a path to an AI that isn't just built, but is grown, an AI that can evolve. As we start giving our creations the power to refine themselves, it leaves us with a really profound question to think about. What comes next?